Hey builders and welcome back. In the last video, we explained why the CDP SQL API is a game changer. Today, we are going to show you how. We are going to build a complete Node.js script that queries the base blockchain from the ground up. We will cover project setup and API key authentication, running your first query to get the latest block data, querying raw event data for powerful analysis, building a whale watching script to get the largest token transfers, and navigating through API limits and handling large data sets. By the end of this, you will have a working script and the confidence to query any on-chain data. Let's get building. First things first, let's get our project setup ready. So we'll initialize a new Node.js project. So I'm already on my terminal over here, and the directory is on desktop. So I'll just initialize a new project first. So we'll initialize the new directory, navigate to a directory, and here we'll run the command npm init-y. So this will initialize a new package.json. Once this is done, let's install the dependencies that we would require for this. So we'll install Axios and .env for the script. So let's hit enter. So once this is done, we will navigate to an ID, and there we will set up the env that we would require for this script. So once you have opened up your project in ID, first we'll set up the .env file. So here you will set up the .env file, and here you will paste the CDP client API key that you will get from the CDP dashboard. So you can just navigate to the Coinbase Global Platform portal, which is portal.cdp.coinbase.com, and here in the API keys you can find the client API keys as well. So once you have copied the client API keys, you just push it over here the env in the client in the format CDP client API key. So once we are done, we'll also set up the type to module over here as we want to use import state. So I'll just set this up to module. And that's it. We are done with the project setup. Now we'll move to developing our script. So now let's create a new JavaScript file. So I'll create index.js, and here the logic for the script would reside. So first we'll start with the imports and the configs needed for the script. So I already have them over here. So first we have Axios for API management and .env for variable environment variable configurations. That is done. We load the environment variables using .env.config, and then we have the configuration like the CDP client API key and API URL, which would be from Coinbase Java platform to query the CDP SQL API. And then we put some conditions to make sure that if the CDP client API key is not found, it will throw a new error. So once we're done with this, we'll start with the various utility function that we would need for the script. So the first function we would need over here is the API request function. So this function would basically query the API and manage the API request and responses. So I already have the function over here. So this is the API request function, and we'll keep the name to run SQL query. So this will be the function which would run the SQL query using by calling the API from Coinbase Java platform. So here we have a try catch block where we first set the headers. So here the most important part is that we set the authorization header to CDP client API key. So we don't have any temporary authorization headers over here. We can directly use the CDP client API key for authorizing all kinds of requests to the CDP SQL API. So this is a permanent authorization header that you would need for querying any kind of SQL queries to the API URL. So make sure that you have set up the CDP client API key properly. And this is why the API management over here is simplified. You just need to use this CDP client API key to query this API. Once it is done, we set up the data for SQL query, and then we do some console logs to show that the query was executed using this function, and then we return the response data. Once that is done, we have the catch block where if there were any errors while executing this function, it would throw the errors and show the error in console as well. Now, finally, we will write our main function, which would query the latest block data from base blockchain. So I already have the function. So this would be the main logic, and the function would be main. And here, as you can see, for getting the latest block query, we get the various data fields like block number, block hash, timestamp, miner, gas used, and transaction call using the CDP SQL API query. So this would be the CDP SQL API query that we would send to the API. And then we use this latest block query variable and pass this to the run SQL query function that we created before, which would basically call the API, and then we console log the results to see what was the latest block on base. And then we finish the try catch block to make sure that if there are any errors, it shows the errors in the console as well. Now let's run the script and see if we were able to get the latest block data on base. So I'll just open the terminal here. And here we'll use the node command to run JavaScript file. So I'll just run node index.js. So it's executing the query. I'll just And yeah, we were able to get the latest block data on base. So as you can see, the result shows the various data that we selected in the uh, CDP SQL API query as well. So here we have the block hash, the block number, the gas use, the miner timestamp, and the transaction count as well. And we were able to do a first CDP SQL API query by getting the latest block data on base. Now we'll take this up a notch and we'll try to get all of the largest USDC transfers on base. And by that, we will create a script which gets all of the whale transactions on base. So to get the latest USDC transfers, we query the base.events table. This table contains the raw event logs from smart contracts. So basically, we look for the transfers event from the USDC contract. So here in the main function, we'll add the logic for whale watching transfers as well. So here, uh, after this, we'll continue our main function, and here we'll start with the query functions for looking up the USDC transfers. So I already have the first block of the logic over here. So let's go through this and see how it works. So first of all, we have the helper function to format numbers with commas so that we can get the human readable format in our console. So here we would basically have a format number function, which basically formats the numbers with commas. Next, we have the query to whale watching top 5 largest USDC transfers. So here we first set up the USDC contract address. So I got this from Basecamp. You can look up the contact address on Basecamp as well. Next, we have the watching query. So this is the main block for this whole logic. So in this whale watching query, as you can see, we query from the base.events table with the event signature transfer event from the USDC contact address, and we get the parameters like sender, recipient, and amount, so that we can format it and show it in the console logs and see which are the top 5 largest USDC transfers. Then we pass this SQL query to our run SQL query function, which would basically use this to call the API. Once that is done, now based on the response, we'll format the response and show that in our logs. So now we will have the client side logic where we have this 10,000 transfers, and we'll basically fetch all of these transfers and format this accordingly to find the top 5 largest USDC transfers. So I already have the code. So basically, in this, we first make sure that the result that we have got is properly set up and we have got the proper response. Then we sort by amount. So we handle begin for large numbers. So here we'll use result.sort to sort by amount. And then we'll sort this by the descending order with the largest transaction first. Once that is done, we get the top 5 transactions and add formatted USDC format. So here we create a top 5 variable, and here we use a sorted transfers dot slice function, and then map the array with all of the various parameters like the sender, recipient, amount raw USDC amount, and the formatted USDC, so that we can see all of the transactions in our console logs properly. Once we have formatted and done with the client side logic of handling the data, we'll console log this and then make sure that the try catch block is done with the else logic as well. So now that we are done with the index.js script, now we can run the script and see what were the top 5 largest USDC transfers on base. So now let's run the script. I'll just clear the terminal over here. And we'll run the script again using the same command. It should be node index.js. I'll just take this terminal up a bit to make sure that we are able to see all of the console logs properly. I'll run this. So first it will run the latest block data query. Once that is done, it will execute the transfer query, and yep, it was successful. We were able to get the top five largest USDC transfers on base from the last 10,000 transfers as well. So as you can see here in the result, we can see the various parameters like the sender, recipient, and the USDC amount. So here you can see we have some transfers which are up to millions, like 10 million USDC, 3 million USDC in just single transfers. And yeah, using the CDP SQL API, we were able to execute such a complex on-chain data query in just under 100 lines. And that shows you how easy it is to set up CDP SQL API for such complex analysis. To keep the platform performant for everyone, there are a few guardrails that you need to be aware of. First, max 10,000 rows per query. Second, 30-second timeout per query. Third, max 5 joins per query. A whale watcher is a perfect example of working within these limits. We intentionally fetch the max 10,000 rows to process in our application. So what if you want to analyze all transfers, not just the latest ones? You implement application level pagination. This means making multiple queries and fetching data in chunks. For example, you could loop through queries using a where clause in block underscore timestamp to get data day by day or week by week. Your application would fetch the data in chunks, process the overall results, and get the overall top transfers. Always use a selective where clause in index fields to keep the queries fast. And there you have it. In just a few minutes, we have set up a secure project, authenticated with the CDP API, and run both simple and advanced analytic queries against live on-chain data. You now have the foundation to build sophisticated dashboards, monitoring tools, or any data-rich on-chain app that you can imagine. For more help, the best resource is the official CDP Discord server. The team and the community there are incredibly active. And of course, always refer to the official CDP SQL API documentation for more information on the schema and advanced examples. For more tutorials like this, make sure to check out heimlabs.com as well. If this guide from Heimlabs was valuable, please hit that like button, follow for more advanced tutorials, and let us know what you're building in the comments below. Happy building, and I'll see you in the next one.